Okay, everyone, hello. We just did these examples in class, and I'm going to go over them again if some of you weren't in class or just need to hear it for a second time. And I might skip around a little bit. I actually do want to do this trig one first, which is example number 7. I think that it looks like it's intimidating, but it's not. So let's take a look. Let me actually just enlarge this a little bit here. Well, there we go. Okay, so this is in our workbook. This is the classwork. Let's see, what page is this? Let me just check here. What page was this? This is page 52 in our workbooks. Okay, so again, implicit differentiation means that you are now finding the derivative of a function or an equation that has x and y, and we are finding the derivative with respect to x. So again, let's get started. So the derivative of, the derivative of this right here, the derivative of sine of anything is the cosine of that anything. The derivative of the sine of apples is the cosine of apples times the derivative of apples. So hopefully by now that we get that point. So the derivative of sine is cosine. So I'm going to go ahead and get started. So cosine of xy times the derivative of what's in here. And the derivative, we have to use the product rule, right? X times y. So the derivative of x is 1 times y. I'm not going to write the 1, just y. Plus the derivative of plus x times the derivative of y. And the derivative of y is 1 dy dx. I'm not going to write the 1. Again, it's just 1 dy dx. Okay? Equals, and the derivative of 1, this one is 0. So we're done. We've taken this original function and we've found the derivative. Okay, so now we're going to solve for dy dx. This is no longer a calculus problem, it's an algebra problem. First thing I'm going to do is I'm going to divide both sides. Let's see here. I'm going to divide both sides by cosine of xy, again, because I want to get dy dx by itself. So these cancel out, and 0 over everything is just 0. So that made that very easy. Let's go back to blue. And so now I'm left with y plus x dy dx equals 0. I'm going to subtract y, x dy dx equals negative y. And my final answer, because I want to divide both sides by x, dy dx equals negative y over x. And we weren't given an ordered pair here to evaluate the function. So that's number 7. Let's actually go right to number 9, just in case we didn't get to this in class. So again, I'm just going to rewrite this as x to the 1/2 power plus y to the 1/2 power minus 1 equals y. So I haven't found the derivative, I'm just rewriting it. Okay, and let's get started. So the derivative of x to the 1/2 we know is 1/2 x to the negative 1/2, so we're done with x. The derivative of y is the same thing, plus 1/2 y to the negative 1/2 times dy dx. And the derivative of negative 1 is just 0, so I'm not going to write it, equals the derivative of y is 1 dy dx. I'm not going to write the 1, just dy dx. Okay, and now we're going to get dy dx by itself. So this doesn't have, let's put everything that has dy dx together. So I'm going to go ahead and subtract this and move this to the other side. Whoops. What was that? Let me just undo that. I'm going to just subtract this and move this to the other side. So now I have, let me actually change colors so you guys can see from step to step. All right, so I have 1/2 x to the negative 1/2 equals dy dx minus 1/2 y to the negative 1/2 dy dx. Okay, so again, remember, I want to get dy dx by itself. So this is dy dx This should have been minus. I subtracted from both sides. Okay, well, take a look on this side. This side, the greatest common factor, or is dy dx. I'm going to go ahead and just factor that out. I'm actually going to erase some of the stuff on the top just to give myself some room, everybody, okay? So let me just erase this. Here we go. And I'm just going to move up here. Let me change colors again. Okay, so now I have 1/2 x to the negative 1/2 equals, I'm going to factor out a dy dx, equals dy dx, open parentheses, 1 minus 1/2 y to the negative 1/2. And if I redistribute this, I'll get the original expression back. So, all right, and it's pretty easy what to do now, right? Just divide both sides by this expression. So I'm going to divide both sides by 1 minus 1/2 y to the negative 1/2. I'm going to do the same thing over here. 1 minus 1/2 y to the negative 1/2. And that's dy dx. So now I have dy dx by itself. However, I'm not done. It wants me to find the equation of the tangent line. In order for me to find the equation of the tangent line, I first need the slope. Well, how do I find the slope? The slope, when you find the derivative, you're finding the slope. And so they give us a point, an ordered pair here to evaluate the function. So that's exactly what I'm going to do. So let's see here. I have, and it's no accident, these are perfect squares. They were kind to us. So let's see, 1/2 times 9 to the negative 1/2 over 1 minus 1/2 of 4 to the negative 1/2. Oops. To the negative 1/2. Okay, this looks messy, but we can clean this up pretty easily. Let's give ourselves a little more room here. Okay. Okay. So 1/2. 9 to the negative 1/2 power is 1/3 over 1 minus 1/2 times 4 to the negative 1/2 power, and that is also, that's 1/2. So now I have 1 over 6 minus 1 minus 1/4, which is the same as 1 over 6 minus 3/4, which is the same as, I'll go down here, 1 over 6 times 4 over 3, and you can reduce if you want. What do we have here? 4 over 18, which is the same as 2/9. So we have the slope, and the slope is 2/9, and I'm going to use point slope form. It didn't specify what format it wanted the equation in, and point slope's a lot easier, especially when you don't have the y-intercept. So my final equation is going to be, and remember, just y-slope is y minus y1 equals mx minus x1. So my final answer is going to be y minus 4 equals 2/9 x minus 9. And that takes care of that. And let's see, what other problems do we have here that we can do? Find the points where the curve of this function has horizontal and vertical tangent lines. Well, horizontal tangent lines are when the slope is 0. So when we'd get, whoops, let me just, I didn't want to write that. That's when m equals 0. And vertical tangent lines, that's when m is undefined. So, all right, so let's go ahead and find the derivative using implicit differentiation, just like we've been doing. Let me see if I can move this up to give us some room here. Okay, so let's see, 25x squared, let's start. So that's 50x plus 32y dy dx. Remember, wherever there's a y, I'm going to put the dy dx, plus 200 minus 160 dy dx plus 0, because for the derivative 400 is 0, equals 0. Okay, so again, let's get dy dx all to one side. So let's see, 50x plus 200 equals 160 dy dx, and I think you can already predict what I'm going to do on the other side, minus 32y dy dx. And yes, I'm going to factor out a dy dx, so 50x plus 200 equals 160 minus 32y dy dx. And my last thing is I'm going to go ahead now and divide both sides by this. 160 minus 32y, 160 minus 32y. And there is the slope of, this is going to help me determine the slope of the tangent line. So let's see here. Let me just erase this, and these cancel out. And that's what dy dx equals. Okay, so we have to find horizontal and vertical tangent lines. So when are we going to have horizontal tangent lines? We're going to have horizontal tangent lines when our slope is 0. Okay, well, when will this equal 0? Simple. This will equal 0 when my numerator equals 0. So when will 50x plus 200 equal 0? Oh, that's easy. When x is, let's see, when 50x equals negative 200, and when and divide both sides by 50, when x equals negative 4. So at x equals negative 4, I'm going to have horizontal tangent line. And what about when it's going to be undefined? And I'm actually going to erase some of this stuff here. I don't need all this. Okay, and when am I going to have undefined, a vertical line? When I have an undefined slope. When is something undefined? When the denominator is 0. Let's set the denominator equal to 0. So when will 60 minus 32y equal 0? So negative 30, whoop, that's a terrible 3. 32, negative 32y equals negative 60. Y equals negative 60 over negative 32. And let's see, what can we divide by? Can we divide by 4? I think we can. Let's see, negative 60 divided by 4. Well, first of all, the negatives cancel out. And I'm left with, let's see, 15 over 8. Let's see here. Did I do that right? Oh, was that supposed to be a 160? That was supposed to be a 160, everybody. Sorry about that. 160. So let me erase that. 160, and 160 over 32 is 5.